So this is a separate video for Thursday, February 11th, when I'm not going to be here. This is one last little part. We skipped this last condition for normal. So I want to actually go in and add that, but add it separate. So there's a problem on your worksheet that you should have for today. It is this second problem right here. And it says, suppose we have this simple or this random sample of SAT scores. What is the 95% confidence interval for the true mean SAT score? So we know sigma, which means we use z. We haven't talked about y yet, but we just know we use z because it's sigma. It says random, so that's good. But when we get to the normal condition, it does not say that the population distribution is normal. Our sample size is only 1, 2, 3, 4, 5, 6, 7. So that's not enough to be central limit theorem. So as of right now, we don't know what to do. So we're going to go ahead and type these into a graph. So if you'll type those 6 numbers into your calculator because I can't show you, I'll write these steps out. So you're going to stat edit. Y'all should know all this. Then you're typing numbers in a list. Then we want to graph it. So we go to second y equals, which is stat plot. In the top left, we want plot 1 to be on. I want all the other ones off. Which type do we want? We want to do a histogram. So this one's like this one. Want to click that one. Make sure that you have your X list as whatever list you're in. If it doesn't show up, you got to hit zoom 9. And it should show something that looks, I'll draw it better, but it basically looks like that. So what we're doing here is we're checking. I'll talk about the definition later, but it's robust, which means if it doesn't look terrible, a normal approximation would still at least be helpful. So we're looking to see, does this look so terrible that I can't use it? So we want to see, does it look fairly symmetric with no extreme outliers? So if I had something like, if I had a graph that was like, I'm probably not going to want to use something like that for normality. It's definitely extremely skewed. It's got outliers. If one of these ended up in the sample, it would really throw things off. Here, regardless of which one my sample is, it probably wouldn't be that terrible. So we're checking for these things. So in your steps, that was my specific problem. In this one, you're going to add to it a third way is to make a histogram of values. I'm going to write draw. I always have people who just think that means they can just say that they made one. Draw a histogram of values. And check if it is fairly symmetric with no extreme outliers. So on this one with the example problem, remember you can do second trace. Or just trace, sorry, not second trace. You can change the window if you want, but because I'm not there to talk about it, I'm not going to do change the window right now. So I would write, this is where I'm going to be checking for normal in this problem. I'm just going to make my title histogram of values. And then so down here, it starts at 950. My next one starts at 1067.5. Probably should have written these like sideways so I could fit them in better. But it's really hard to write on this digital board thing sideways. This one is 1185, 1302.5. So I would probably have chosen to change my settings to where I'm changing my X scale to where it's not dealing with a decimal. But like I said, when I'm actually in front of you, I'll talk about that, and you don't have to do it. So these are of the same height as these. And these are twice as high. Wasn't a very straight line. So these are frequency, and I could just put values. It's a histogram of values, and I'm going to put off to the side that it is. So I've already written histogram of values here. If not, I would need to write it over here. And I write fairly symmetric. And no extreme outliers. And we're checking normal conditions, so I still always have to write, so we can use normal approximation. So when you're doing this problem on your worksheet, this is exactly what you should fill in as you're checking normal. So back to that worksheet. This one, it gives you simple random sample of 20. Mesh, I don't see, I'm looking for the word normal. Doesn't look like they've told us that the population distribution is normal. My sample size is not big enough. So here is one where I would have to do my histogram to be able to check it. So 2 and 4, you're going to have to draw your histogram as your normal condition. Now, just so that you see, this one says, what is the confidence interval? What is confidence interval? This one says how large a sample. I haven't talked about that yet. I'm going to do that Friday. Construct a 90% confidence interval. How large a sample. We haven't talked about that yet, so don't do that one.